Alright, what is the ratio? Hopefully this is the last video. I'm pretty sure it is. What is the ratio of x to y? We gotta know what x is, we gotta know what y is. So listen up, okay? What do we do here? Well, first thing I can do for part A is I notice that I can write these with the same base. And once we have the same base, we can set the exponents equal to each other. So I can say, first of all, actually, before I start doing that, ratio of x to y, that's just the same thing as x over y, yeah? So that's what I'm trying to get, x over y. See what that is. And in this case, I can do 2 to the x equals 2 squared to the y, which is the same thing as 2 to the x equals 2 to the 2y. So once I have the bases the same, the exponents must be equal. So I can say x equals 2y. And now I notice right here, I can just divide by, I could write this down. X is 2y and y is just y. And then, well, I feel like that might be confusing for people. But if I divide both sides by y, then I get x over y. That's what I wanted. And x over y equals 2. So the ratio of x to y is 2. Now, let's do something with something a little bit more complicated. I guess it's not that much more complicated, because here we cannot match the bases. These are both prime numbers. We can't match them. So what do I do? What do I do? Well, anytime you have exponents that are variables that you want to solve for, you can use logarithms. So I'm going to take log base 10, let's say. So I take log base 10 of both sides. That's allowed. But then I can use my rules that say I can bring the x out in front and the y out in front. And then I'm going to do exactly what I did before. So I have x log base 10 of 2 equals y log base 10 of 5. And I want x over y. So I'm going to divide both sides by y. So that goes away. And I almost have x over y, so that's great. And then I have log base 10 of 5 over there. I want to get rid of this, so I'm going to divide both sides, which is the same thing as multiplying by 1 over log base 10 of 2. And I'll do that to the other side. 1 over log base 10 of 2. Beautiful. That goes away, and I just have x over y, just like I wanted, because it asked for the ratio of the two. So this is log base 10 of 5 divided by log base 10 of 2. Sweet. So that's all it was asking for. Now, I have 10 here. You don't have to write 10. When you don't write any base, it implies that it's base 10. But we didn't have that there. And that's what you get. Isn't that beautiful? Maybe one more example. Systems of equations. Okay, let's look at that. Last one. Systems of equations. They're not very difficult. Hopefully you're comfortable with them by now. But if you have two variables and so two unknown values and two equations, you can solve for both of the values. And that's what we're going to do here. I think one of the most common ways to solve these is elimination. It's probably, in my opinion, the simplest. And what I want to do is I want to make, choose my x's or my y's, and it doesn't matter which one. I'm going to choose the y's to cancel out. And something might happen with this. I don't know. Maybe everything cancels out. And then I'm going to eliminate those variables. So I want to make them the same number but opposite signs. So I'm going to multiply this one by -3 and this one by 2. Then I get 4x, right, because I have to distribute all the way through, plus 6y equals 62. And then in the bottom I also have to distribute, so I get -9x minus 6y equals 3 is 60, 78, -78. No, -87. So after that, I add the two equations together. So, and the whole point was to get these to cancel. So now I have, what is this? Negative 98765. Negative 5x equals 87 minus 62. But the 87 is negative, so that would be negative 25. Divide by negative 5. And then we have x equals positive 5. So, great, but we're not done. That was just half of it. We want the y-coordinate as well. So I'm going to choose the top one, so 2x plus 3y equals 31. You can choose any equation, but plug in the value that you found. So here is going to be 5. So I have 2 times 5 plus 3y equals 31. So that's 10 plus 3y equals 31, minus 10, 3y equals 21, divide by 3, and then what do we know? We got the answer, we get 7. So we have 5, 7. This represents the point in which these two lines intersect. It's like a graph. It's the point where they intersect. That's the solution to 5, 7. All right, that's it. We're gonna have a good day now. Adios.